Good morning, my fellow mathematicians. My name is Maki D, and today I am going to be taking you through a Level 2 Further Mathematics GCSE exam. This exam is designed to be challenging with some of the most difficult questions you could be asked at GCSE in this paper, but I am prepared to take you through these and show you how they are all done. So without further ado, guys, let's get right into this exam. So the first thing to note, guys, is the formula sheet. There are a number of formulas on here which you should probably all know by now. First we have the volume and surface area of a sphere and the cone, respectively. You guys should know that already. It's not too difficult. Then we have the trigonometric formulas, the area of a triangle, the sine rule and the cosine rule, which you will learn at GCSE mathematics. There is also the quadratic equation, which you are also supposed to have learnt for the normal GCSE, but there are two more identities which you may not have come across before, which are tan of theta is identical to sine of theta over cos of theta, and that sine squared of theta plus cosine squared of theta is always equal to 1. You will not have come across these identities at normal GCSE before, but they are very important for the Further Mathematics GCSE exam. It is important to note that the sine squared of theta basically means sine of theta squared. So in other words, it means sine of theta squared, like that. But we just write it like that for convenience sake. Alright, so let's get into the exam. So the first question in this exam is y equals x squared bracket x minus 10, and what it is asking us to do is to work out dy over dx of that equation. In other terms, find the derivative of y equals x squared x minus 10. So the first thing we do is to expand out these brackets so you have an easy to work with equation. So we can expand this out by doing x squared times x, which is x cubed, and then doing x squared times minus 10, which is minus 10x squared. Then we can easily find the derivative of this by using the formula, which is to multiply by the power and subtract 1 from the power. So we can put 3 in front of x to get 3x to the power of 3. But then we subtract 1 from the power, so we have 3x squared for the first term. We can do this for the second term as well, by multiplying it by 2. So we have minus 20, and then we can subtract 1 from the power, so we have minus 20x. And this is our answer for the first question, guys. Boom, guys, we did it! That was insane! For this second question, we actually have matrix multiplication to work with here. So this one is not too difficult, as we have one row, one column and 2 rows, so it's not too difficult. And the 4 out here means that we have to multiply the inside of these, each term in the inside, by 4. So we can do this with the first one. So we can do 4 times 1 equals 4, and 4 times minus 2a, which is minus 8a. And we can do it with the bottom term as well. So 4 times a equals 4a. So this is our expanded first matrix. And then we set this equal to b12. So we know that 4a is equal to 12. So we can write this as an equation. And then we can divide by 4 to find a. So a equals 3, and we can write this in. Boom, guys! And then we can substitute a as 3 into this minus 8a. So we have 4 minus 8 times 3. This dot is just another term for multiplication. You could also use the cross as the times sign. And this is equal to minus 20. So therefore we have b equals minus 20. Wow. For this next question, guys, we are given the nth term of a sequence 3n over 5n plus 12, and we are told that a term in the sequence is 1/2. So now we have to use that to work out the position of the term, which is equivalent to n. So what we can do in this scenario is to set the nth term equal to 1/2 and solve it for n. So we can write 3n over 5n plus 12 is equal to 1/2. And then we can multiply it by 2 to get 6n over 5n plus 12 equals 1. Then we can multiply it by 5n plus 12 to get 6n equals 5n plus 12. And then we can subtract 5n to have n on its own, n equals 12. So the position of 1/2 in this sequence is 12. For this next question, 3b, it asks us to find the limiting value of this sequence as n tends towards infinity. So what this means is that as n gets really big, this sequence is a converging sequence, so it will tend towards a specific value. So to do this, we need to factor out n from the numerator and the denominator. So for the numerator, this is kind of easy. We can just factor n out of 3. So we write n3 as this, just to make it easier. And then for the denominator, we can factor out n from 5n. So we have n 5. And then we can factor it out from 12, giving us 12 over n. Then what we can do is we can cancel out the n from this fraction, giving us 3 over 5 plus 12 over n. And what it's asking us to do is to find the limiting value as n tends towards infinity. So what we can do with this equation is to make n equal to infinity, or a really big number. And as you know, the bigger the denominator is, the smaller the actual fraction is. So as n is infinity, this value is essentially 0. So what we're given is 3 over 5 plus 0, or just 3 over 5. And that is our answer. Question 4 gives us the equation of a circle, which is x plus 5 squared plus y minus 8 squared equals 10. 4a asks us, what are the coordinates of the centre of the circle? Circle your answer. So for this one, we need to understand the generic equation of a circle, which is x, so bracket x minus a squared plus bracket y minus b squared equals r squared. The x and the y are the variables of the x and y axis, a and b are the coordinates of the centre of the circle, and r is the radius of the circle. So what we are given here is x plus 5 and y minus 8. So minus a is the x coordinate of the centre of the circle. So since it's plus 5, we know that the centre coordinate must be minus 5 for x. And the same goes for y. Minus b is the y coordinate of the centre of the circle. So since we are given minus 8, we know that the centre coordinate is 8. Therefore giving us 5 minus 8. Minus 5 and 8. Yeah. Which is that one. Wow, that was epic gamer talking right there. We can also use this equation for this next question, which is write down the radius of the circle. And since we know that the radius is r squared, which is 10, we know that the radius must be the square root of 10. So we can literally just write root 10. You must always check to see if this surd can be simplified down, but in this case it can't, so we just leave it as root 10. Question 5. A, B, C and D are points on a circle, centre O. Work out the value of x. So for this question, we need to use two separate circle theorems. The first one being that the angle at the centre of a circle is twice the angle at the circumference when the angles are subtended by the same arc. And the second circle theorem is that opposite angles in a cyclic quadrilateral sum to 180 degrees. So using the first circle theorem, we have 2x plus 48 is the angle at the center, so we can use this to work out the angle ABC, which is half of this angle at the center. So angle ABC is half of 2x plus 48, which is equal to x plus 24. And then we can use the second circle theorem, which is opposite angles in a cyclic quadrilateral are equal to 180 degrees. So angle ABC plus ADC equals 180 degrees. So x plus 24 plus 3x equals 180. We can simplify this to get 4x plus 24 equals 180, and then we can subtract 24 from this to get 4x equals 156. Then we can divide by 4 to get x equals 44. And that is our answer. Question 6. mx plus 4 minus 2 brackets x plus p is identical to 6 bracket x plus 1, where m and p are integers. So it asks us to work out the values of m and p. So it is important to note that this is an identity, which means that the variables and the constant must be the exact same. There cannot be any changing with it. So what we must first do is to expand this identity and then simplify it. So we can expand it first. Mx plus 4 minus 2x plus 2p is identical to 6x plus 6. We can move the 4 and the minus 2x to the right hand side just to have mx and 2p on their own, so we can actually solve this identity. So we can write mx plus 2p is equal to 8x plus 2. Since this is an identity, we know that mx is always equal to 8x and that 2p is always equal to 2, because these values must be the exact same and they are identical. If this was an equation, it would be much different, and these values could be anything because we have two different constants here which could be any value. But it is identical, so we know they must be equal to 8 and 2. So we just write m equals 8 and p equals 1, because 2 times 1 equals 2. Question 7 gives us a quadratic inequality and asks us to find the possible values of x to satisfy this inequality. So essentially here we are given a quadratic equation, but it is an inequality. But we can treat this like it is a quadratic equation and factorize it, so to find the values of x. So to do this, we need to find two numbers that add to get minus 20x and two numbers that multiply to get 96. And these numbers must be the same. So we can write down all the factors of 96. So we have 1 96, we have 2 48, we have 3 32, we have 4 24, we have 6 16, 8 and 12, and I believe that's it. So out of all these, there is only one which can add to get minus 20x, and they can multiply to get 96, and that is 8 and 12. And how do we get plus 96 and minus 20? Well, they can both be negative, which means that minus 8 minus 12 is equal to minus 20, and minus 8 times minus 12 is equal to plus 96. So this is our factorized quadratic equation, x minus 8, x minus 12. And so to find out the inequality, it is much easier to draw this as a sketch. So we can draw a little quadratic equation or quadratic graph here. So the roots are plus 8 and plus 12. So we can draw an approximate thing. It doesn't have to be completely accurate, as this is just a visual aid. So 8 and 12 go here. And to find where it is less than 0, it has to be below the x-axis. So it is in between 8 and 12. So the values of x, for which x squared minus 20x plus 96 is less than 0, is when x is in between 8 and 12. So we just write 8 is less than x, which is less than 12. Note the use of the less than sign here and not the less than or equal to. We must use the same type of sign here. If this was a less than or equal to sign, we would also use a less than or equal to sign here. But we don't. So, following from this, in the question it actually says, work out the integer values for x. So, I worked out the inequality, but for the question you actually have to write down the actual values that x can be. So, you have to write down 9, 10, and 11. So, the bit about the inequality sign is correct, which means you don't write 8 and 12, but you have to actually write the numbers in to get full marks in this question, which I didn't do. So I got this one wrong, unfortunately. Alright gamers, question 8. Solve 3 minus root x to the power of a third equals minus 2. So, the power of a third, according to indices rules, is that the numerator is the power and the denominator is the root. So since we have the denominator of 3, this is equivalent to the square. The cube root of 3 minus root x equals minus 2. So we can write this down. So the cube root of 3 minus root x is equal to minus 2. Then we can cube both sides of the equation to give us 3 minus root x is equal to minus 2 cubed, which is minus 8. And then we can subtract 3 from both sides of this equation to give us minus root x equals minus 11. And we can multiply both sides by minus 1 to get rid of this negative sign here, giving us root x equals 11. Finally, we can square both sides of the equation to give us x equals 121. So just like that, we've solved for x. Question 9 asks us to expand and simplify x minus 5 cubed. So this is a cubic equation, or cubic expression, since there is no equal sign, and it is asking us to expand it and give it as a cubic expression. So the easiest way to do this, first only worry about 2 brackets. So this would be fully written as x minus 5, x minus 5, x minus 5. But we can just worry about these 2 first and ignore this. So we can work out this quadratic expression first. So we can easily do this as x squared minus 10x, because we have minus 5 times x plus minus 5 times x. So we have minus 10x. And then we have plus 25, because minus 5 times minus 5 is equal to 25. Now, we can use this quadratic equation, and then we can multiply it by the final bracket which we have left over. So, written in full would be like this. And then we can multiply each of the terms by the x and the minus 5 separately in this bracket. So first, we can do x squared times x, which is x cubed, minus x times x is minus 10x squared, 25 times x is 25x, x squared times minus 5 is minus 5x squared, minus 10x times minus 5 is plus 50x, and plus 25 times minus 5 is minus 125. So then we can simplify this by collecting the like terms. So we have 1x cubed, we have 2x squared, so minus 10x squared minus 5x squared is minus 15x squared. We have 2x terms, so we have 25x plus 50x gives us 75x. And then we have one constant on the end, which is minus 125, giving us x cubed minus 15x squared plus 75x minus 125 as our cubic expanded and simplified cubic expression. Question 10, guys. The fourth root of x equals 2 and y to the power of minus 2 equals 25. X is greater than 0 and y is less than 0. Work out the value of x over y. So first we need to find out the exact value of x, and then we can find out the exact value of y. So first we can raise both sides of this equation to the power of 4. So that would get rid of the fourth root. So we have x equals 2 to the power of 4, which is equal to 16. So that gives us x pretty easily. Then we have y to the power of minus 2 equals 25. And according to indices laws, if you have a negative power, that is equal to 1 over y to the positive power. Or in other words, y to the power of minus 2 is equal to 1 over y squared. So we can write this down as 1 over y squared equals 25. And then we can multiply this by y squared, giving us 1 equals 25y squared. And we can divide this by 25 to give us 1 over 25 equals y squared. We can then take the square root of both sides to give us the square root of y equals the square root of 1 over 25. To take the square root of a fraction, you can just do the square root of the numerator and the denominator at the same time. So we have root 1 over root 25 is equal to 1 over 5. But, as given in the question, y is less than 0, so we must note this down as a plus or minus a fifth. But it cannot be... Shut the fuck up. So we must note this down as plus or minus a fifth. As given in the question, y is less than 0, so it cannot be positive a fifth, so we must have y equals negative a fifth. So now we have to work out x divided by y. So we have 16 divided by minus a fifth. So what this does is we can flip the fraction and change the sign so we have 16 times 5 over negative 1, giving us 6 times 5 divided by negative 1, which is 80 or minus 80, because dividing by 1 does nothing, but divided by negative 1 changes the sign. So we have negative 80 as our answer. Our epic gamer squad. Okay, question 11 gives us 3 points, A, B and C, and states that they are on a coordinate grid. Show that the lines segments AB and BC are perpendicular. So for this question, we need to know that how to check if two line segments are perpendicular. This is quite easily. So the gradient of one of them is equal to negative reciprocal of the other gradient. So the gradient of AB is equal to -1 divided by gradient BC. So we can keep this in mind throughout this question. To find the gradient of AB and BC respectively, we can visually see this by plotting the points on a sketch. So we can draw the axes. This isn't necessary, but it can be easy for an aid. So we can have A as 1 1/5 and 3 and 4/5. We have B as 2, which is slightly further along, and 1 4/5, which is not as far up. And then we have C, which is 5 and 3, which is very far along, but not as far up as A. To find the gradient of AB, it is equal to rise over run. So we have the rise, which is the y-coordinates, or the difference between the y-coordinates, divided by the difference between the x-coordinates. So we can do 1 4/5 minus 3 4/5, giving us -2, over 2 minus 1 1/5, giving us -4/5. We can do -2 divided by -4/5, which is equal to -2 divided by -4 times 5, which is -10 over -4, which can be simplified as 5/2. I think. Except that that's not minus, so it is -5/2. Yeah, okay. We can then use the same logic to find the gradient of BC. So we can do 3 minus 1 4/5, as we are finding the difference between the y-coordinates here, giving us 1 1/5. We can also find the difference between the x-coordinates, which is 5 minus 2, which is 3. This fraction is probably easier to write as 6/5, as we are dividing the fractions eventually. So we can divide the rise over run. So we have the rise, which is 6/5, divided by 3, which is 6. We can just do the numerator, which is 6 divided by 3, giving us 2/5. As seen here, the gradient of AB, if these lines are perpendicular, is equal to -1 divided by the gradient BC. So we have the gradient AB, -5/2, and we have the gradient BC, which is 2/5. This is also called the negative reciprocal, and to find the negative reciprocal, we change the sign, making it either negative or positive, and we can flip the fraction. So we can clearly see here that this fraction is the negative version of this one, and it is also flipped around. So yes, these fractions are perpendicular. So yes, they are. But you would also have to like write the shit in like this, you fucking... I'm not even going to edit this out. Just write the AB gradient. Gradient AB. Oh, voice crack. Nice one, mate. Gradient BC. So yeah. I don't fucking know. Yeah, just do that and you're good. Alright. Question 12. You are given that x squared plus 6x plus 2 is identical to x plus h squared plus k. Work out the values of h and k. So this is basically a completed square form of x plus 6x plus 2. So we can actually just complete the square for this. So that would give us x, the brackets x plus b over 2a, so 6 over 2, which is 3, squared, and then we can find 3 squared equals 9, and to get us back to 2, we have to subtract 7. I noticed that was a bad tutorial on completing the square, so I will now go through my steps again, hopefully. So, this may be easier for you guys to understand, but an easy way to complete the square is using this formula as a x plus b over 2a squared as this bracket bit, where a is the coefficient of x squared and b is the coefficient of x. So we can see here that there is no coefficient of x squared, or as it seems, but it's actually 1. So a in this case is just 1, and b is equal to 6. So Mackie D bloopers. So we have x plus 6 over 2 times 1, which is just 2, giving us 6 over 2 is 3. So we have x plus 3 squared, and since a is equal to 1, we just we could write 1, but we just don't. And then to get this minus 7 here, we can actually expand out this bracket here. So we have x squared plus 6x plus 9. And since x squared is equal to x squared and 6x equals 6x, we don't have to change this. But 9 does not equal 2. So to get from 9 to 2, we need to subtract 7. So we have minus 7 on the end of this bracket. And since this is identity, as given by the previous question on the identity, these values must be the exact same. So h equals 3 and k equals minus 7. Oh, there's more. Okay, so write down the coordinates of the minimum point of this equation. So to find out the minimum point, it is just the negative of that plus and that as the y-coordinate. So you would need to complete the square for this usually, but since we've already done that, we can just write it out. When y equals 0, x must be equal to minus 3, and when x equals 0, when this equals 0, y equals minus 7. So we have minus 7 and minus 3, minus 7 as the minimum point. Then we have 12c. So to solve this equation, we can just write the completed square form as an equation. So we have x plus 3 squared minus 7 equals 0. We can add 7, giving us x plus 3 squared equals 7. We can take the square root, which is x plus 3 equals plus or minus root 7. Then we can subtract 3, giving us x equals minus 3 plus or minus the square root of 7. I did that very quickly. Yeah, you can pause to understand. But yeah, we just write that so x equals minus 3 plus or minus the square root of 7, where a is minus 3 and b is 7. Question 13. Solve root 125 plus root 20 equals root 80 plus root x. So we can simplify this surd, and we can simplify all three of these surds here to give us a common surd, which we can then add up. So we can start one at a time. The square root of 125. The largest square number that goes into 125 is 25. You can check if you want, but I've done it already. So 5 root 5 is equal to 125. Then we can do the same with root 20. So the largest square number that goes into 20 is 4. So we have root 4 root 5, or just 2 root 5. So 125, or root 125 plus root 20 equals root 5 root 5 plus 2 root 5 equals 7 root 5. We can do the exact same thing with 80. We can find the largest square number which goes into 80, which is 16. So we have root 16 root 5 is equal to, which equals 4 root 5. And then we have plus x, root x on the end. So we can write this as an equation. So 7 root 5 equals 4 root 5 plus root x. We can move this 4 root 5 to one side by subtracting 4 root 5. We can just treat this root 5 as any other algebraic term. So we can just subtract 4 from 7, giving us 3 root 5 equals root x. But since x is on the inside of this square root, we need to find what goes into this square root, what 3 root 5 is equal to. So we can do the opposite of finding the surd, or simplifying the surd, expanding the surd. So 3 is equal to the square root of 9. So 3 root 5 is equal to root 9 root 5. And surd multiplication, or surd laws, means that the square root of 9 times the square root of 5 is equal to the square root of 9 times 5, which equals root 45. So we found that x is equal to root 45. So x equals 45. That was pretty epic. Sort of. Okay, so question 14a. X minus 3 is a factor of x cubed minus 8x squared plus ax plus 42, where a is an integer, and we have to prove that a equals 1. So we know that this is a factor, so we can do the reverse of multiplying out the brackets like we did in a previous question. So remember how we wrote a quadratic equation times the other bracket, so we can do the same thing here. So x minus 3 times a quadratic equation equals that. So we know that x times x squared is equal to x cubed, and you can only multiply by 1x squared because there's only 1x squared in a quadratic equation, and there's only 1x in here. So we know the highest has got to be the x cubed. So we can just easily figure that out. We do this by dividing that by that, giving us that. We can do the same thing here with the plus 42. We can divide that by minus 3 to give us what is the constant in this quadratic, which is minus 14. And this bit in here is a little bit harder, but we know that minus 8x squared is equal to minus 3 times x squared plus x times something x. So we can just write this as plus kx, where k can be any number, and we know to get to minus 8x squared we have to do minus 3x squared plus x times kx, which is kx squared. and that gives us minus 8x squared. We can add 3x squared to both sides, giving us kx squared equals minus 5x squared, and so we know that k has got to be equal to minus 5. So now we know this quadratic equation is x squared minus 5x minus 14, so we can use this to find ax, which is here. So we can write this quadratic equation again, x minus 3, and then x squared minus 5x minus 14, and we do minus 3 times minus 5, which is plus 15x, and then we do x times minus 14, which is minus 14x, giving us x on its own. And thus we have proved that a equals 1, as we don't write any coefficient there, which is pretty epic. And again, so we've already done this, so we need to factorize this fully. So we know that one of the factors is x minus 3, and we've written that this quadratic equation is x squared minus 5x minus 14. And then we can just factorize this quadratic equation, giving us x, x plus 2 and x minus 7. You could write the factors of minus 14 if you want. I can't be asked. So therefore, yeah, the fully factorized equation is x minus 3, x plus 2, x minus 7, which is pretty peng. There we go. Whoa, look at this. T-shirt and pen change. This may or may not be a different day where I accidentally skipped out a double page in this exam. No, that would never happen. So we're going to continue this as normal. Question 15, rationalize the denominator and simplify fully 6 over root 7 plus 2. So to do this, we have to actually multiply the top and the bottom by the same thing on the bottom, but flip the sign. So that is root 7 minus 2. So we have to do 6 over root 7 plus 2 times, and we're going to use the epic dot multiplication, root 7 minus 2, and we have to do that on the top and the bottom, because this fraction is actually equivalent to 1, so we aren't actually changing anything here, but we're just making it so that it is rational. So we can do this, we can multiply the top out first, which is 6 root 7 minus 12, and then we do the same with the bottom. This is actually going to result in the difference of 2 squares, so we can just literally multiply the first and the last. The other two will just cancel out. So we have root 7 times root 7, which is just 7, and then we have 2 times minus 2, which is minus 4. So that gives us 6 root 7 minus 12 over 3, and then it asks us to simplify fully, so we can divide it by 3. So we can divide that term and that term by 3 at the same time, sort of thing. So we have 2 root 7 minus 4, and then we can actually simplify again. We can factorize this as both the terms have a factor of 2, so that actually gives us 2 root 7 minus 2 as our final answer, which is insane. That would have been 3 marks I missed out had this been an actual GCSE. So yeah, everyone makes mistakes, guys. Let me refer to my notes. Question 16. Angle theta is obtuse and sine theta equals root 11 over 6. Work out the value of cosine theta. So this one is actually a pretty fun question. So we actually have to use the good old identity sine squared theta plus cosine squared theta. You little cunt. I knew this was going to happen. I may or may not have... I wonder if I'll edit this in or not. I don't know. I mean, edit it out or whatever. No, it'll be in the bloopers at the end. I don't care. Fuck my life. Don't fall over again, you piece of shit. You fucking little... God's sake. This is why you don't use a guitar stand as your tripod. Let this be a lesson to all you aspiring maths tutorial people out there. Okay, so we have sine squared theta plus cosine squared theta equals 1, or is identical to 1. So we can square this, giving us sine squared theta is actually 11 squared. So root 11 squared, which is 11 over 6 squared, which is 33. And then rearranging this, we get cosine squared, or cosine squared theta, equals 1 minus sine squared theta. And since sine squared theta is 11 over 36, cosine squared theta equals 1 minus 11 over 36, which equals 25 over 36. And then we can find cosine theta, which is plus or minus 5 over 6. Now we have to use this plus or minus because it says angle theta is obtuse, and this is very important because if we draw in a cosine graph, which I'll sketch it out, but it looks a little bit like this, I think. So that's 180 and that's 90. So we know the definition of an obtuse angle is it must be between 90 and 180 degrees. So it must be one of these values here. And we know that all these values are actually negative. So we must take the negative value of cosine theta, which is 5 over 6. So the answer is minus 5 over 6, not plus 5 over 6. That would be wrong. So there we go. Now let's fast forward or rewind back to past Mackie D with my other t-shirt and other pen. Alright, question 17. The diagram shows a sketch of the cubic curve y equals a third x cubed minus x squared minus 3x plus k, where k is a constant. The x-axis is a tangent to the curve at its minimum point. Work out the value of k. So, to find out the minimum point, we need to find out where the derivative of this equation is equal to 0, because we know that the gradient of the curve at the minimum point is 0. So, we can find the derivative, dy over dx, of this is equal to 3 times x times a third, which is 1, and then we subtract the power by 1, giving us 1x squared, or just x squared. 2 times minus 1, which is minus 2, and we subtract the power by 1, giving us minus 2x. Since that is just x to the power of 1, we can multiply that by 1, leaving it as minus 3, and we subtract the power by 1, and anything to the power of 0 is 1, so we just have minus 3 times 1 on its own, or just minus 3. And we know that we just discard the constants for other reasons. And yeah. So this is our gradient function, x squared minus 2x minus 3. And so we need to find what x is when the gradient function is equal to 0. So we have x squared minus 2x minus 3 equals 0. This is just a quadratic equation which we can factorize. And I've done this off camera. x minus 1, is it? Yeah. And x plus 3 equals 0. And so we
know that x equals plus 1 or minus 3 when the gradient is equal to 0. So when it's here, it's minus 3, but we don't need that. Run like this way.
And yeah, that's it. 3 2/3 is yeah. Okay guys, looking back on this question, it appears that I made a small mistake which eventually messed up my answer. So when I factorise this quadratic equation, it turns out that it is actually x plus 1, not x minus 1, which kind of changes our answer a bit, meaning that that is x equals minus 1 and that is x equals 3. So we have to change that, meaning all of this is bollocks. So we can do the exact same thing when y equals 0, x equals 3. And we can do the exact same thing that we did here, but x is actually 3. So 0 equals 3 cubed divided by 3, which is 9, or 27 divided by 3, which is 9, minus 3 squared, which is minus 9, minus 3 times 3, which is minus 9, plus k. And we can simplify this, giving us 0 equals minus 9 plus k, which means that k equals 9. So there we go. There is our answer when I was not an idiot. Question 18. Factorize fully x to the power of 4 minus 81. So for this question, we need to know the difference of two squares, and I'll just briefly run through that. So if you have x minus a and x plus a, you can expand out these brackets. You get x squared minus ax plus ax minus a squared, and those two cancel out, giving you x squared minus a squared. This is the difference of two squares because we have two square numbers and they are subtracted, and we know that if we have the difference of two squares, that they can be factorized into this form. So we can apply this knowledge to x to the power of 4 minus 81. So we know that x to the power of 4 is x squared squared, so we can have x squared, and we know that minus 81 is actually 9. We know that 81 is 9 squared, so since we have x squared squared minus 9 squared, we can write that as x squared plus 9 and x squared minus 9. So this is our factorized version of this. However, you can also notice that we have another difference of two squares. X squared and 9 are both square numbers. So we can factorize this once more, giving us x plus 3 and x minus 3. Overall, we have x squared plus 9, x plus 3, and x minus 3 as our fully factorized expression. You can expand this yourself and you'll find that it equates to that. So yes, that was cool. Question 19. ABCD is a square, CDE is a straight line, AC is 3 root 2, and angle DEA equals 60 degrees. And we are asked for 19a to show that the side of the square is 3 centimeters. So for this, we can actually use Pythagoras Theorem, which states that a squared plus b squared equals c squared for any right-angled triangle. And since this is a square, we can see that this is clearly a right angle. and this gives us a right angled triangle ABC. So we can just draw this. I'll draw this here. So we have the side length of x and the hypotenuse is 3 root 2. So using Pythagoras' theorem, we know that x squared plus x squared equals 3 root 2 squared, or 9 times 2, which is 18. So we can simplify this, giving us 2x squared equals 18. And we can then divide by 2 to give us x squared equals 9. And therefore x squared, or x, equals the square root of 9, which is 3. You could use you could write this as plus or minus the square root of 9, but since this is a square, we cannot have negative measurements, so we have to write the positive number, which is 3. 19b. Show that the perimeter of trapezium ABCE is 3 times 3 plus root 3 centimeters. I might need to refer to my notes for this one, which is going to be pretty epic. Yes. So, since we know that the side of the square is 3 centimeters, we can just write that in for all 4 sides. And we can actually use trigonometry because this is a right angled triangle. As stated in the question, CDE is a straight line. So therefore, since this is a square, this angle CDA is 90 degrees, and therefore 180 minus 90 equals 90, so ADE is also 90 degrees. So this is a right angled triangle, and this has side length 3. So therefore, we can use sine of 60 is actually equal to the opposite over the hypotenuse, 3 over h. I will label this h, and I'll label this a, because that's the adjacent, which we'll find out in a bit. So, this is actually one of our special trigonometric values that we can actually figure out. And I'll show you how to do that, actually. So, if you have a equilateral triangle, I'll make it big, with side length 2, it has a angle. The angles of it is actually 60 degrees. So if you were to half of it, we know that this is 1, and Pythagoras' theorem, we can work out this is root 3, and so sine of 60, which is opposite over hypotenuse, is root 3 over 2. So I kind of rushed through that a bit, but sine 60 is root 3 over 2. Just trust me on it, please. So we can actually multiply by h and divide by sine 60, giving us h equals 3 over sine 60, which is 3 over root 3 times 2, giving us 6 over root 3. And I will rationalize this denominator to give us 6 root 3 over 3, because we multiply this by root 3 over 3, because that is just equal to 1, so we are literally just keeping it the exact same, but getting rid of this denominator, the third. So that gives us 6 root 3 over 3, or just 2 root 3. So we have found that AE equals 2 root 3. Now we just need to do the exact same thing for A. So we know that tan 60. So using this triangle again, we also can do that tan 60 is the opposite over adjacent, which is root 3 over 1, which is just root 3. So tan 60 equals root 3. So tan 60 in this example is 3 divided by A. As again we have the constant on the bottom, So we can multiply by a and divide by tan 60, giving us a equals 3 over tan 60. And since tan 60 is root 3, we have a equals 3 divided by root 3. Again, we are rationalizing the denominator here, so we can multiply it by root 3 over root 3, giving us 3 root 3 over 3, or just root 3 on its own. So we can just write that in. So, now that we have all the side lengths of this trapezium, we can add them up together. So we have 3 plus 3 plus 3 plus root 3 plus 2 root 3. And to simplify that, that gives us 9 plus 3 root 3. And this can be factorized. We can factor out 3 from both of these terms to give us 3 bracket 3 plus root 3. And that is what is given in the question. So we have proved that the perimeter of the trapezium is that. So yay. Oh, what a banger. I also have notes for this question as well. So that's also pretty cool. Yo guys, we have made it to the last question on the paper. This is the most epic gamer question out there, and it is pretty challenging, but luckily I have the ability to show you guys the answer for it. But if you would like to know the answer to this question, I ask you to like the video and subscribe to the channel if you're new, just to make sure that you have the ability to actually watch this and comprehend the epicness of this answer. Also, if you're enjoying the video so far, make sure to comment down below that you are in fact enjoying the video. All your moral support gives me great encouragement to make more epic gamer videos like this and more mathematics videos in the future to go on the MackeyD channel, guys. Alright, so this is pretty exciting. In the triangle PQR, cosine of P is equal to 1/3. Show that the triangle PQR is isosceles. So, to do this, we actually have 3n, 2n, and w on this triangle. We cannot show that 3n equals 2n, because for that to be the case, n would have to be 0, and this triangle would not exist. So, we actually have to prove that w is equal to either 3n or 2n. So we can do that. We can do this by using the cosine rule, which I will remind you of, which was in the beginning of the paper. It is on the formula sheet, so you don't have to remember that. I just hit my camera. So we have a squared equals b squared plus c squared minus 2bc cos a, but we actually can use this alternative form, cosine a equals b squared plus c squared minus a squared. So I will just write that down so I don't have to keep turning the page. Oh, this exercise. Look at all that. So, cosine of a, but I will write cosine p because it's easier, and we'll label the sides a, b, and c respectively. Cosine p equals b squared plus c squared minus a squared all over 2 times bc. And since cosine p is 1/3 as given in the question, we can actually write all the terms in as given here. So we have 1/3 equals b squared, so 2n squared, plus c squared, plus 3n squared, minus a squared, which is w, all over 2 times b times c. So 2 times 2n times 3n. And this equals 4n squared plus 9n squared, which is 13n squared, minus w squared, over 2 times 2n times 3n, which is 12n squared. What we can then do is we can cancel out 3 and 12, which gives us 1 equals 13n squared minus w squared all over 4n squared. Yeah. And then we can multiply it by 4n squared, giving us 4n squared equals 13n squared minus w squared. Then we can subtract 4n squared, I think. Yeah. We can subtract 14n squared from 13n squared, giving us 0 equals 9n squared minus w squared. This is actually a difference of 2 squares again. So 9n squared is a square number and w squared is a square number. So we can factorize this, giving us 3n plus w equal and 3n minus w equals 0. So we know that for this to be equal to 0, these numbers would have to be plus w, w over n, 3n or something like that, and or minus w over 3n. We know this because for it to work in this one, we would have to divide it by 3, I think. Let me rephrase that slightly, because I suck at explaining. So for n, to find the roots of this n equation, we need to find n, and for n to be equal to 0, in this bracket we would have to have minus w over 3, because we need to divide it by 3 to get rid of that, and then we subtract w to get rid of that. And in this one it would be plus w over 3, because we divide it by w and we divide it by 3 and add w to get rid of that. But this is negative, so we can't have that. So we have to keep w equals w over 3, which is positive. So n equals w over 3 to make that equal to 0. What we can then do is we can multiply both sides of this equation by 3, giving us 3n equals w. And this may not look like much, but we have actually proved that this side is equal to this side here. And therefore we have proved that this triangle is isosceles, because, let me write that down, PQR is isosceles, because two of the side lengths are the exact same, and this is the definition of an isosceles triangle. And I spelled that wrong. So yeah, that was fun. Not sure how I enjoyed my explanation for this, but if you guys want to see more epic daily content like this on the MackyD channel, make sure to like the video and subscribe to my channel if you are new, so you don't miss any other epic content like this. Also, if you have any other epic gamer suggestions, make sure to leave them down in the comments section below, so that I can make more epic daily content like this for you guys, and fishing for the views, guys. So, that's going to wrap it up for this video. I hope you guys enjoyed it. Make sure to stay revising your foundation mathematics, and yes, that is going to be it for you guys. I hope you guys enjoyed this. I've said that about 50 times already. Goodbye.
Da 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 da.